Discussion of finding the region for the given boundary conditions. So we are working on the concept of parabolas. Now, previously discussed when line equations are given, how to draw the region when line equations are given. Now let us see curvical structures. Like here you can see it is y square equal to x square equal to y. So if you have y square or x square, the structure is curvical image. So here you can see it is a x4 plane. So we have x-axis, y-axis because the 2D structure. X-axis, y-axis, 2D structure. So y square equal to x. We have already studied that there are 4 types of parabolas. Am I right? There are 4 types of parabolas. So if I say y square equal to 4ax, y square equal to 4ax, you have to see this x is positive. So along the x-axis, you have to draw the curve. So here it is y square equal to x. This is a general form. This is a general form. So in the place of 4a, it is 1 here. So if I draw a random diagram like connected with this idea, so I can draw like this. You can draw like this. This is a parabola. So let us consider this as parabola with y square equal to x equation. Y square equal to x equation. Now, what about x square equal to y? Again, we can think of the general form. X square equal to 4ay. X square equal to 4ay. So here you can see y is positive. So y is positive. So along y axis, the positive direction, we can draw the curve. We can draw the parabola curve. So here, this is the general form x square equal to 4a parabola that is open upward. So if I draw here for x square equal to y, so the x square equal to y, the curve goes like this. The curve goes like this. So here the point is, am I right? 0, 0 point, 0, 0 point. So this is our region. So this is our bounded region. This is our bounded region. Y square, x square equal to y. So this curve is y square equal to x, and this curve is x square equal to y. Now this point is 0, 0. So how do I understand this point? How do I understand this point? So you can solve these two equations in order to get the point that can be done. So for example, you see it is y square equal to x. Am I right? Y square equal to x. And the other equation is x square equal to y. There are two ways. One is substitution method. You can apply one equation into the other and you can factorize and find the point. The second method is you can take some values and understand for which value, for which x both the y's are equal, for which y the both x are equal. So for example, so let me take this one. If I apply x equal to 0, if I apply x equal to 0, in this equation is x equal to 0, what about y? Y is also 0. Am I right? Y is also 0. When I apply x equal to 0 in this equation, what about y? Y is also 0. So I could write y is equal to 0. So now I can understand that one point is one of the common point. Common point for these two equations are 0, 0, 0, 0. Okay, let me take another x value when x is equal to 1. Okay, when x is equal to 1. When I apply x equal to 1, what about y? Y is also 1. Y is also when x equal to 1, I get y as 1. So the point is 1, 1 point. 1, 1 point. So what about this? When x equal to 1 here, for the next equation, when x equal to 1, what about y? Y is also 1, that is y is also 1. So the point is 1, 1. So these two points are common. See, 0, 0 is a common point for both the equations. and 1 comma 1 is the common point for both the equations. So I understand that if this point is 0 comma 0, this point can be 1 comma 1. Can be 1 comma 1. So this is graphical way of understanding the intersecting points. So like this you can understand the intersecting points, you can understand the region, these vertices. So by which in further maybe using integration you can find the area. So this is how you can draw a picture for a given set of parabolas. Okay, thank you.